this point, I could take questions from you. That's my granddaughter. She says thanks. Even I thought this is solved.
I'm glad we were able to thank our speaker. Any more questions from the audience? Otherwise, people can come up and talk to Sundar, and he will explain things more to them.
I have a few more slides. I can go through some of them quickly, and then we can say at the end all questions. Okay. My family pictures are here. I want to thank Professor Rita Labova, who is here. She's a professor of mathematics from Russia, retired. She helped proofread the whole paper, thoroughly checking every equation. And then Peter Schultz is the CTO's office at Lincoln Laboratory. He's an associate CTO. Associate. She's a technology officer. He spent 3 days. A 3-day week, long weekend we had. So he went through that. He wrote a letter saying that I'm amazed that you're able to eliminate T0. And then Charles Taylor is a friend of mine, colleague from Lincoln Lab. He was in the Warren Commission, the only scientist on that commission when JFK was shot. He was the only scientist on the team. Charles Taylor is famous for DSP work. He wrote the first book on digital signal processing with the gold and radar, which was the syllabus book for me back in IIT days in Chennai. And then I had numerous other people that helped me, but these people really did a thorough job. And Ravi Vedala did a wonderful job. He's also a mathematician. I have a love for mathematicians, by the way. Even Lincoln Lab, I always hang around the mathematician there. Here's my son, who's a lieutenant commander in the US Navy. He's an electrical engineer from RPI. He also has a law degree. He recently saved the Navy $2.6 billion. He found some fraud going on there. When he went to the GAO, they refused to take his complaint because it's too high up in the hierarchy that he's complaining about. So he went to McCain personally to introduce a bill in Congress and close that loophole. So he went extra length to save that money for the Navy. Great guy. This is my daughter on the left, I am on the right. She married a Russian, she lives in Prague. She's a death metal singer called Abnormality. She went to mass art major. She's also a great artist. This is the rest of the family. There are my daughters, 3 daughters together, 3 sons there, my granddaughter always reaching to me. Okay. And then this is the daughter that went to New Zealand. She was a polo horse trainer in New Zealand. This is my house in Gardner. I was going to explain what the RSA is. I won't do that now because that will take time. Where prime number is used. That, by the way, was discovered at MIT. Again, distribution of prime. Riemann started this work when he was looking for how to count the primes. How many primes are there under x? X being a number. You pick a number, x. The prime number theorem says it's approximately x over log of x. If x is 100, just substitute x is 100, there you'll get a formula. Of course, the logarithmic integral called Li, that is a little bit more accurate because it deals with density functions instead of fixed constant probability. And then Riemann hypothesis, if it is true, the error bounds is the tightest error bound, which is the square root of x accuracy. So that's the best possible prediction for the prime numbers. So Riemann, if he was right about it, it will be square root. If it is 3/4, then it will be x power 3/4. Whatever the straight line that all the non-trivial zeros belong to determines that error bounds. And this is I am familiar with rotation called Gibbons rotation, which is everybody familiar with that. Two corners are cosine, the other corners are plus or minus sine. Plus or minus and minus are plus, and then reverses in the other diagonal. This is called Gibbons rotation. It's a 2x2 unique rotation matrix. So I built a chip that was published in the proceedings of in a conference in San Francisco years ago, and I built that chip. That chip, you can see 2 inputs and 2 outputs, and theta being a rotation angle. Either you give it to it or it comes out, depending on whether it's a master or a slave chip. So the question was, how do we do this for complex case? Inputs themselves, the 2 inputs could also be complex within complex. So that makes it a 4-dimensional situation. I went to Charlie Rader. I asked Charlie, do you know anybody that has worked on this? He smiled at me. He said, no. He smiled. He said, listen, me and Professor Morph at Stanford butt our head together for 10 years to do the same thing for a complex case. That means complex inside complex, to build a chip. He said the result was nobody can solve it. So I wanted to go work on some other problem. Don't waste your time. So I went upstairs to my desk. I just meditated for 1 minute. I came back running with my chalk in my hand. He said, what, you solved it? I said, I just meditated on one of the gods of the Hindu mythology called Shiva. He came out of the third eye of Shiva. So I said, you know everything, so you should help me. So he said, okay, you opened up this into 3 factors. Factorization is hard. Even if you look at the RSA algorithm, once you multiply the 2 prime numbers, how do you factor it, or which 2 prime got you that result is hard. It's a long process. It may take 100 years. So the same thing happened here. And the matrix 2x2 matrix, which will be a complex in this case, the vectors are going to be complex entries. So here's the one complex 2x2 matrix. I solved that, and I also found that's not unique. Not like the Gibbons rotation is unique. There's no other 2x2 matrix. But for complex case, there are at least one other one I know can do the same thing. But this one, I liked it because this I can implement into a hardware. And the hardware looks exactly like the other one, identical to that chip, but I need 6 of them connected that way. So this is what I showed him in 1 minute. I ran to my office, came back and showed Charlie this picture. He just almost fell out of his chair. He said, how did you do it? Let's be quiet now. We'll keep it a secret. He called the DoD for $60 million. He built a chip immediately based on that for a 64 channel. This takes about 2 channels. So if you like, it looks like a similar to FFT butterflies, and then you have to have branches going back and forth. No external circuits. It's all, you can build this to any dimensions you want. And he built 64-dimensional chip. There it is. It's a supercomputer by itself. It's one chip that you hold in your pocket that solves 64 jammers coming at you, try to jam your fighter plane, and you can manage all those 64 guys. Because you put a null in every one of them. This is a dynamical situation. You're flying at high speed, and all the jammers are unpredictable. Everything is collected and processed and taken care of. You're computing all the weight vectors and put a null in the direction. It's like putting your hand against the sun when you're driving, but you have 64 suns you have to manage at the same time. You have to have 64 or 65 hands, one for the steering wheel. So that is the end of my slideshow. Now is the good time for questions. How did I do on time? Curious.
Much too fast.
1 hour. I went too fast, but it's elementary. It's all high school math. I didn't use anything sophisticated other than e power I theta is cos theta plus I sin theta. If you don't know, I can explain what that is. It's very easy.
We're actually going to have recording this, so we should be able to make a recording available.
Yeah, that's the hardest question is e power I theta. You try to find out e power I theta equal to. It's called the Euler's identity. Just Google or YouTube Euler's identity. You should know how to spell Euler. E-U-L-E-R identity. And then it'll explain that. One thing I understood was if you differentiate e power I theta, you get I times e power I theta. Sorry, I times e power I theta, and then if you differentiate the right side, cos theta, sin theta, then you'll match. That's one way of testing is correct or not. Why is that equation true? Because you can take log on both sides of derivatives. If it comes out to be equal again, that means it's true. Thank you. And what is any slide number that you want questions asked? Do you know anybody?
You mentioned a paper. Is the paper available online? Do you have a URL?
I have the PDF format. I can give it to you. Anybody that, of course, send me an email. I'll send you that, gladly send you that. It's written as a paper. I've been circulating privately with people. Is there I think it's right next slide.
No, let's go back.
Well, the title. Did I miss that?
Yeah, you did. Go back.
Go back. Somewhere there. Okay, there's it. Can you copy it? China and then YA. China@AOL.com.
How did you get that name?
I'm not the AOL. Chennai means junior in my language, Tamil. By the way, Ramanujam was a Tamil guy. He lived about 10 miles away from me. We drank the same river water. There's a small river that goes through his town, Kumbakonam, comes to my town. Not ours. So I had a great inspiration from him when I was in Liverpool. Somebody told me, do you know about Ramanujam? I said, who is he? He said, it's great mathematician. Then I said, okay, I should read about it. So he's a great inspiration because he didn't go to college, I don't think he came to spiritually. He also explained that spirituality clears your mind and drops all those equations on you. It's very easy. So when I was meditating, I have no idea that the 2 by 2 complex matrix would factor into 3 simple matrices. Once you do that, then implementation in the hardware is so easy. I did that. When I went to IIT Chennai, the 2 professors both got their PhD from US, one from University of Illinois, one from University of Iowa. So they both sat with me, said they wanted to guide me to the master's degree by research. So it's 2 years minimum. It can go on to 4 years or 5 years if you don't do proper research. They said I will give you help you, give you a problem that you can solve. It will take you approximately 2 years. We'll help you. So I took that problem. By 4 o'clock, I solved that problem. I gave it to them, both of them on the desk. They stopped talking to me after that. They said, you do whatever you want. So I worked on the FFT error analysis. I found a correlation from different parts of the flow chart. These correlations are assumed to be independent. Statistically easier to calculate if they're independent. You can add the variances together. And I found the simulation was half of what Cliff Weinstein and Lincoln Lab predicted. I said, why is it only half? So I wanted to know where that factor 2 comes from. I solved that by actually calculating the correlation coefficient, theoretically, plus practically matched. So I did that. Lincoln Lab, I worked on some of the surveillance problems, radar, penetration aids, decoys, and image processing. But I think the reputation, Peter Blankenship said one time, reputation is that if nobody can solve at Lincoln Lab, we'll call you Sundar, he said. I don't know if he's flattering me, but he was a very kind person, Peter Blankenship. He was the division head. So I did a sincere job. The thing is, the education in general, you have to understand the foundation, fundamentals. If you miss the fundamentals, it doesn't matter how big a building you build, it's going to collapse. The foundation, math, science, physics, in this country, chemistry, all those that has to be taught at high school level, really strong. Then this country should come back, regain the status in the world. So I'd like to thank Peter for arranging this talk in a short note. Peter has been negligent. I sent him this request June of 2018. I proposed this talk. He waited one whole year, almost a year. By the way, it was May 24th, 2000 is when the Millennium Problem was read out in Paris by Andrew Wiles, who was the leading speaker in Paris conference. The Millennium Problem, the seventh problem was mentioned, that was May 24th. Today is May 23rd. It's been 19 years tomorrow. So I saw Riemann hypothesis within 19 years. Thank you very much. And Poincaré's was solved, I think, 2003. 3 years. Within 3 years after announcement, he was fantastic. Russian mathematicians are very advanced. They are deep. They don't work for money. He refused the $1 million prize. And he lives poorly with his mom, no money. So they don't care. So thank you all for coming, and if you have no question, I'm going to be here. You can talk to me in private about your question. If you want, email me. Every one of you that emails me, I'll send you a PDF right away. Okay, you can read it. And you may have a question about the L functions and all those things, or the generalized Riemann hypothesis and all that will follow the same approach. And I have tested some on the L functions as well. It follows similar. If the zero, the critical line happens to be sigma equals 0, I show that coming out the same way. So you have to be, the equations you use should be valid in the region. Otherwise, you have to make that equation to be valid before you go into analysis. There's the reason this problem remained for 160 years. You want to know why wasn't it solved before? It's simple, 5 reasons I found out. One is it's a 4-dimensional space. It's not easy to grasp how the rotation takes place. And of course, I spent years and years on the rotation matters, especially multidimensional situation. So it came easy for me in that sense. The other problem is the analytic continuation, because the original zeta function is defined only for sigma greater than 1. So when you go here, they act very weird. The properties of the analytic continuation is that it creates zeros where you are not having it first to start with. When you do an extension, like in my case, you see the extra factor appeared. That's a natural phenomenon that happens in the analytic continuation. You create more zeros somewhere you didn't expect, and then you have to deal with that. In my case, it became simple because Hadamard and the Valley, they already proved there's no zero for set of function on sigma equal to 1 line. That came out handy. And by the way, I have one last thing I forgot to mention. The series, when you sum it, if it's an odd number, remember I showed you for a partial sum of 513, it's essentially be odd. If it's even, it gives you sigma equal to 1 as the answer, because that's the other factor. Remember, don't forget that factor that appears anytime, doesn't matter what length. If it's even, it happens there, 1, sigma equal to 1 line. I have to insert it in the paper, just mention that, maybe footnote, if you want, it has to be odd. Because of the way all the cosines and sines are added, it shows some kind of limit cycle phenomenon in that. But I expected that to happen. So, thank you very much for coming. And anybody in private can talk to me. I'll be here for a few minutes. Thank you.
Thank you.
My wife, who's like sitting way back, she's not a mathematician, but she helped a mathematician to survive. She didn't kill me. Okay, thanks.
Enable, like we want to.
She's the enabler.